Let's take a look at this example here. This is going to help us understand simple interest and hopefully different compounding frequencies. So Greg invests $1,200 into an account that pays 4% per year. And we want to know what is the amount in the account after, and I change it from 5 to 10 years if the interest is simple, and then compounded annually, semi-annually, quarterly, monthly, and daily. So here we go. Simple interest. Remember, the interest doesn't change. So first we need to find 4% of $1,200. Okay, 4% as a decimal. Whoops, my hand was there. 4% as a decimal is 0.04. When you're finding a percentage of something, you multiply that decimal by the number, and I get 48. Okay? So my interest every year is just $48. So you might imagine that after 10 years of $48, we make $480. Sorry, I'm having some trouble with my pen here. $480. Okay? So and they ask for the amount, not the interest. 480 is the interest, right? But we want to add that to the 1,200, and we get $1,680. Okay? If interest is calculated using simple interest. Now, mostly interest is compounded, meaning it gains interest on interest. Of course, loans are that way. So compounded annually, that means once a year. So let's take a look at what P is, what I is, and what N is. Okay, P is our principal, it's $1,200. I is our interest rate per compounding period. So if it's annually and it's given as 4% per year, then it's just 0.04, which represents 4%. Okay, interest rate has to be a decimal. N is, in this case, because it's annually, is just the number of years. So I changed to 10. Okay, there's our what we need to input into our formula. And so we have 1,200. 1 plus 0.04 to the power of 10. And if I calculate that, I can simplify this to 1.04. Put that into my calculator. I should get $1,776.29. Okay, there's my units right there, $sign. Let's take a look at semi-annually. Alright, principal stays the same, so I'm not going to write that every time. I'm just going to figure out what I and N is for every situation. Okay. N, I, N. Okay, let's figure out what our variables are for the formula. So semi-annually, that means 2 times a year. So my interest rate of 4% per year is going to change to 2%, so 0.02. It's going to cut in half. That's 2%, right? Okay. And N is going to be the number of years, so it's 10 years, 2 times a year, so 20 altogether, right? So now I'm going to have A is 1,200, that doesn't change. 1.02 to the power of 20. Make sure that you use brackets in your calculator and that you do not press equals after anything except for after the exponent. You will get the wrong answer. It's very important that you plug everything in right, otherwise you're going to get the wrong answer, and it's very important that you double check too. Plug it in twice, don't be lazy. Alright, so now we get a little bit more interest because we're calculating interest on interest earlier. Let's look at quarterly. So now we have 4% divided by 4, which is 0.01, 1%. We're calculating 4 times a year for 10 years, so that's 40. 10 times 4 is 40. And so we have something very similar to the power of 40. And we get $17.86 and 64 cents. $sign. Alright. Monthly. Here's where it gets interesting because my interest rates are not very pretty numbers. So let's take a look. Monthly. So let's do 0.04 divided by 12. And on my calculator I get 0.0033, repeating. Okay, so let's say I round to 4 decimal places. N is 12 years for 10 years. 10 times 12, 120. Always years times compounding periods. Alright, so if I were to do this, I would get 1200, 1.0033 to the power of 120. And I get 1781.88. Now, that should look weird to you. It's less than before. And I've done the calculation correctly. What I have done is I've rounded this number here, and that gives me actually the wrong answer. So this highlights the importance of making sure you keep all your decimals. So I actually don't want you to round the interest here. So I'm going to delete all this. What I want to do is just add 0.04 divided by 12. I'm going to keep that in my calculator to the power of 120. Okay? So when I plug this into my calculator, I do times, I do a bracket, plus 1 plus 0.04 divided by 12. It'll do the division before it does the addition. Bracket to the exponent 120 equals. No other equal sign in there. And then I get 1788.999. Make sure you round correctly. Okay, this 9 is bumping up, that 9 is bumping up that number there, so it should be 1789.00. Okay, there's our new number. So let's use the same kind of process for the compounding daily. My interest rate then is going to be 0.04 divided by 365. I'm not going to calculate that because it's going to be messy. My number of compounding periods, N, is going to be 10 times, well, 365 times in every one of those 10 years. So that's 3,650. And when I plug this into my calculator, I get plus 0.04. So again, I have to write this out because it's not neat. And if I round, I'm going to be totally messed up. It seems like it's going to be a huge number because of this. But remember, this decimal is very, very small. And I get 1790.15. Okay, so you can see what's happening to my numbers. They are rising because I'm compounding, I'm calculating interest more often. I hope that clarifies any misunderstanding. Good luck.